Okay, going to summarize up the working on the horizontal curve. When I give you the horizontal curve, you'll be given the delta, the degree, which is how many degree of the curve of the circle per 100 foot of curve, and the PI, which is the point of intersection, which is the station number. First thing you should do on this is take your delta, which also remember later, your delta is also your I, which you'll be using in your formula later. Let's go ahead and turn your 18, 13, 30 into a decimal degree, which will be 18.225. Put parentheses around it. Later in the formulas, you're going to need to know what 1/2 I is, so I go ahead and divide that by 2, 9.1125. Did the same thing with my D. Turn 22 degrees, 30 minutes, 45 seconds into 22.5125. Point of intersection 1725. Okay, you'll be asked to find the R, the T, the L, the PC, the PT, and the LC. Okay? The radius. The formula is 5729.58 divided by D. The 5729.58 is a constant. You will always have that number. It'll be the same number every time. Okay? In this case, divided by D, we've turned D into 22.5125. We divided it. We came up with 254.51. Next, you're going to get the T. It's a tangent. You're going to get the T. It is R times the tangent of 1/2 I. And remember this, we're going to do the tangent of 1/2 I, okay? It's 0.1603 times R, which was this. We came out with 40.82. And remember, that is a feet. That is in feet. Then we're going to get the L. The L, remember, is the length around the curve, not straight across. It's not this, okay? So we're going to do L. Do 100 times I over D. And remember, I is going to be your delta. And remember, do not use 1/2 I for this. Use the 18.225. 18.225 divided by 22.5125, which is your D, or your degree of curve. It's going to equal 0.8096. Multiply that times 100, and we got 80.96. That is the length around the curve, okay? Then we got to find out where the curve starts and where the curve ends. Okay, the PC is you take the PI, which is the point of intersection. Remember, it goes up, and then it comes back down. Subtract that T from it. We came out with T. Okay, the PI is given to you at the beginning of the problem, 17.50 minus 40.82. We calculated that. We found the T earlier. Equals 17.09.18. These are station numbers. If they're station numbers, they also represent feet. So don't put feet. Make sure you put your plus back in your number after you do your calculations. And only go 2 decimal points out because we can't measure into thousands when we're surveying. Okay? And at the end of the day, that is what we're doing here. Okay, then the PT is the point of curve from that station, which is 17 plus 09.18, which we just calculated, plus the length of the curve, which we calculated earlier, which is 80.96, equals 7090.14. That is a station number. Make sure you put your plus back in there, okay? Then the very last thing is your long curve. Your long curve, your formula is going to be 2 times R times the sine of 1/2 I. We've already calculated that 1/2 I out there earlier. Okay, 2 times R, this is R, 509.02 times 0.1584. Remember, that's half of that. Okay, and you're going to get 80.63. And the way to kind of know that this is right, we're looking at this, when you start getting your mind wrapped around what you're doing, remember, this degree is 22 degrees, 22 and a half degrees of a circle is 100 foot of curve. So if you look at this circle right here, make a little illustration. Here's 0, here's 90. That's about 45 degrees of curve, so about half of that. So that's not a very steep curve, is it? It's not a very steep curve at all. So the length of that curve, which is the L, is 80.96. So going around the curve is 80.96. This LC, which is the long chord, is a shortcut. It's a straight line between here and here. Okay, they're almost the same, but this LC should always be shorter. Now it's not much shorter, like looking at 0.63 and 0.96, but that is such a flat curve that that's the way it turned out. So that's the way to kind of look at this and start thinking about it. So when you start getting curves out in the field, start looking at it and figuring it out. And like if looking at that way, and if I would have seen it was, 50 feet apart, I was like, wait, something's wrong. So that's why you learn to catch the mistakes that's on the plans and just learning to read that. All right, you guys can do one of these now? All right, we're going to see.